Hi guys! In today's video we are talking about solving equations by adding or subtracting. So this is like what we have seen on our bell work before. Maybe you don't quite remember, but I'm going to show you. So we have them usually on our bell work. There's one that says like b plus 5 equals 10, something like that, and I say solve for b. And you have figured out by now that you can kind of look at it, or you can subtract 5 from both sides, and when you do that you get b equals to 5. That's all we're doing in this lesson. So we're going to talk about a couple properties that help us to do this. So the addition property of equality means that if I add the same number to both sides of an equation, it's going to keep it equal. So if I add something to both sides, remember equal means they're the same. I had a teacher once show me the idea of a scale here. So it's got a balance. If I've got something over here and the same idea over here, so there's the same box, same size, same weight, then my scale is going to be balanced. If I add something over here, it's going to fall to that side, but if I add something of equal size and weight over here, it's going to stay balanced. That's the idea with these properties. I'm going to add the same number to both sides to keep it equal, and the subtraction property says that I can subtract the same number from both sides of an equation and it will also stay equivalent or equal. So back up here to our little scale, if I took this piece off of both of them, they would still stay balanced. Inverse operation. Inverse means the opposite. So the opposite operation. So that means if I have a plus, the opposite is a minus. If I have a minus, the opposite is a plus. So just like we did up here, b plus 5 equals 10, I subtracted 5 from both sides. I did the opposite. I had a plus, so I did the opposite. I subtracted to make those cancel out and go away. So I used that subtraction property. I did the same thing to both sides. I kept it equal, and I did that inverse operation. Okay, you're already pretty familiar with these. I just wanted to kind of remind you that that's what we're doing. Now we're going to go on to some new examples. So on this example, will you please change this to a plus 23 right there? If we do that as a negative 23, we can. It'll just make things a little bit harder because we're not super familiar with negative numbers yet. Okay, so the goal of solving this, which we'll see in just a second, is to get the variable on one side all by itself. So write variable right there. So just like we did up here, we got rid of that 5 to get the b by itself, so then we knew what b was equal to. That's what we're going to do right here. So the first thing that we want to do to solve this is we want to separate the two sides of the equation by drawing what we call railroad tracks, okay, on each side of the equal sign. And I'll show you what I mean with that. Go ahead and write down equation and equal. Railroad tracks, all I do is, so I've got my equal sign right here, I'm going to draw a line down like that and another line down like that, so it kind of looks like railroad tracks if I have the little cross pieces in there. This is where our equal sign's going to go in just a minute as we simplify and move things around. Next, I want to circle the variable and everything attached to it. Okay. So my variable is this x, and it's got that plus out in front. Remember, I'm circling the operation that's in front, not behind. So I have 5 plus x equals 23. Now, to get the variable all by itself, I want to use the inverse operation. So I'm going to do the opposite of what's happening. So let's look at that. If I look at this, I need to get x by itself, and the positive can stay with it. That's fine. I need to get rid of that 5. There's nothing written in front, so is it plus 5 or minus 5? Remember, we talked about this in some notes a while back. If there's nothing in front, it's positive. That's a positive 5. I have a 5 there. So to do the opposite, I'm going to subtract 5 from both sides. That's my subtraction property. Minus 5, minus 5. So if I do something, number 4 right here, if I do something to one side of the equation, you must do it to the other side. If I don't, if I only subtract 5 from here, it's like just taking one of these shapes off and leaving the other one there, my scale is going to be unbalanced. It's going to tip up, okay? We want to keep everything balanced, so we're keeping everything the same on both sides. So minus 5, minus 5. When I do that, this cancels out. It goes to 0. If you want to write like a big Z or a big 0 through it, you can, or you can just cross them out. They equal 0. So I have 0 now plus x equals, and I'm going to subtract over here, 23 minus 5 is, if I take my 23 and my 5, I can borrow. 13 minus 5 is 8. 1 minus 0 is 1, so I get 18. Remember, I changed that to a positive 23 right there. So I get x equals 18. So that was this fifth step. We're going to solve for the variable by combining the numbers on the other side of the equal sign. So right over here, I combine these together, and I solved for my x. Now I want to check my solution by plugging it in. So this is what we did last week with checking solutions. Remember where you plugged in the number and you wrote yes or no, it was the same. That's why we practiced that, so that we're ready to check and see if we did this correctly. So if I plug in my 18 right here, I'm going to have 5 plus 18 equals 23. Okay, so I just put that 18 in place of my x. 5 plus 18, if I add those together, 18 and 5, 8 plus 5 is 13, 1 plus 1 is 2, I get 23. And I'm going to check, is 23 equal to 23? Yes. So since those are equal, I know that I solved this correctly and I got the right number. If I did it and it was not a solution, I'm not going to stop there. I would write no, but then I'd come back and I'd have to fix something over here to find the correct solution. If you've got a question about what I mean by that, ask me in class, okay? So let's try a couple more together. So remember, we're going to start by drawing our railroad tracks on either side of the equal sign. We're going to circle our variable and any coefficients or operations that are attached to it. We're going to do the inverse operation to get rid of all the other numbers, because remember, we're trying to get that variable all by itself. Whatever we do to one side, we have to do it to the other side. We can't just do it to one. Then we're going to combine everything and solve, and then check our solution. Okay, so right here, I'm drawing my railroad tracks. Step 1. Okay, step 2, I want to circle my variable and anything attached to it. This x is all by itself. Remember, it's kind of like a 1x, it's positive, but this plus is attached to that 1, okay? It's not attached to my x. So now I want to do the inverse operation to get rid of any other numbers. This one is adding, so the inverse tells me to subtract. And since I did it to this side, I've also got to do it over here. 1 minus 1 is 0. Those go away. 10 minus 1, I'm ready to solve that, is 9. So over here I'm left with my x. My equal sign stays in the middle on my railroad tracks. And over here I have a 9. I'm going to check that my x is by itself. Everything over here is simplified and combined, so I'm done. I get x equals 9. Now, in this space right here, I'm going to check that and make sure it's right. So I'm going to plug in 9 for my x. I'm going to get 9 plus 1. I'm going to draw my equal sign, and they said it's equal to a 10. Let's see if that simplifies and is true. 9 plus 1 is 10. Set that equal to 10 over here. That just came straight down. Is 10 equal to 10? Yes, that is true, so I solved this correctly. Okay, let's try number 2. So I'm drawing my railroad tracks right down like that. I'm going to circle my variable and anything attached to it. Again, this one's out in front, so it's just the a by itself. Now I want to do my inverse operation. So now this time I have a minus 8. So I want to do the opposite, and I'm going to add 8. Okay, if I'm subtracting, the opposite is to add. Since I did it over here, I have to keep this balanced and add 8 over here. Negative 8 plus 8, or 8 minus 8, cancels out. That goes to 0. So I'm left with a right here. My equal sign stays in my railroad tracks. 150 plus 8 gives me 0 plus 8 is 8, 5 plus 0 is 5, 1 plus 0 is 1, so I get A equals 158. Draw a box around that, and then I know I'm ready to check this. So, over here, 158 minus 8 equals 150, because I had 8 minus 8, so A minus 8 is 150. Let's check and see if that's true. 158, take away 8, leaves me with 150. I had 150 over there, so yes, this is true. We found the correct answer. Okay, go ahead and try these on your own. Follow these steps. If you get stuck, ask me in class. Bye.